Have you ever wondered about the physics behind Olympic sports?
Well, if your answer is yes, let us introduce you to the physics behind one of the oldest sports of this competition, the hammer throw.
This discipline has been included in the Olympic Games in the men's category since 1900 and in the females one in the 2000s. This sport consists of throwing a hammer made of a metallic sphere with a minimum standard mass of 7,260 and a maximum of 7,285 grams in the men's category, and about of 4,000 to 4,025 grams in the women's category. This will be attached to a cable with a handle to hold for the launch.
In this test, the athletes will have to challenge themselves to throw the hammer as far as possible. This act has to be carried out in a circle with a diameter of 2.135 meters, making 3 to 4 turns. Here, the period and the frequency have to be taken into consideration. The first one refers to the time an object takes to complete a lap. This is reciprocal to the frequency, that is the number of laps that an object makes in 1 second.
First, we need to know that the movement the hammer makes is known as uniform circular motion, which occurs when an object moves at a constant speed and a constant radius along a circular path. Even though the velocity of uniform circular motion is constant in magnitude, it's not constant in direction. It's always changing. This means that there is acceleration and there must be a force acting on the object undergoing circular motion.
This is when the athlete has to use these concepts in his favor. They have to understand that the more force applied, the longest distance the hammer will get. So they have to manage to use the centripetal force. This force tends to move the hammer outward, but the pitcher is pushed in the opposite direction. If the athlete wants to take advantage of this force in the best way, they should not oppose it, since with this generates a greater force, so the hammer will achieve a greater distance.
As previously mentioned, when there is a constant change in the velocity direction, there will be an acceleration because the centripetal force provides the body with it. This kind of acceleration is called centripetal acceleration, which will help the change in the direction of the velocity and will always be directed towards the center of the circle. One important fact is that it will be in charge of the variation experienced by the linear velocity because these two are perpendicular.
The athlete must know how to handle this acceleration to let the hammer go in the desired direction. If he knows the concept of tangential velocity, he will know that the hammer will be shot tangentially to the circumference, and not in a curved way as it is mistakenly taught.
As we can see, everything really tends to achieve only one thing: the greatest tension between the hammer and the athlete so that when the hammer is released it reaches an optimal distance.
I'm pretty sure Sergei Litvinov, the Olympic champion with a record of a throw of 84.80 meters, knew all this to have achieved such a feat.